Hope everything's going well in the course. This is my second video. Uh, I guess I've received some positive interest from some of you, some positive feedback. So we'll keep trying to see how this format works. I notice as I do this, every little mistake kind of comes out, so bear with me since I'm the ultimate of video amateurs. Let's get back into the course material. Hope it's going well, and as I say, if you have any questions, feel free to contact me. Email works best. As you recall in my last video, I asked a simple question: why are things round? And here's our friend the orange. The orange is round. Many things are round. Of course, not everything is round, and you may ask, why isn't a banana round, so on and so forth. But many things are round, especially when we talk about large bodies like planets, stars. They take on the characteristic of being round. So why is that? And this is to provide you some insight. The reason why things are round is there's something special about round things. You might almost consider them to be the perfect geometric object. Why is that? Well, what characterizes a sphere is it's an object that has, for a given volume, a minimal surface area. In other words, if I was to take any other geometric figure, let's take, for example, a cube. If I had a cube that had the same volume as a sphere, the surface area would be larger. So, and if you do that for a pyramid or any other object, you'll see that that's the case. So, it is the most compact object. And now when things form, things like stars, like planets, they want to form in the most compact way. They want to form in such a way that there's minimal energy. And the energy here is what's called a concept called gravitational potential energy. And to get into the most compact, efficient form, they form into spheres. So the natural formation of any body is sphere. Now what do we mean by formation? Where do stars come from? What are stars made out of? What's a planet made out of? Well, basically, they have an origin. Their origin starts with little molecules that aggregate into dust particles, that aggregate into larger particles, and eventually they stick together. What makes them stick together is the next question, and the next thing I'd like to discuss. Sticking together is a result of forces. There are different types of forces in the universe. Electromagnetic force is a very common one that creates electricity and magnetism. And then there's a very pervasive force, which is the force of gravity. So you go through this course, you see how important gravity is. It is really the thing that holds the universe together, governs the behavior of many systems. The orbits of the planets around the sun are governed by gravity. The fact that we're sitting here on Earth and not floating around somewhere is due to this force called gravity. What gravity basically is that every piece of mass is essentially attracted to every other piece of mass, and the force of attraction depends on how close they are for each other. So if I have two objects, let's suppose the tip of my fingers was two masses, and the closer they get, the stronger the force, and therefore the stronger the force, the closer they want to get to each other. So gravity is really what's called an attractive force. So let's get back to our little concept here. When particles come together, they start to attract each other, and as they grow, the mass of that effective particle gets larger, and therefore the gravitational field gets stronger, and there's even more of a tendency to pull things together. So eventually, something small, there's a seed, starts to get more things around it. It says more things, it starts to collect more. So starting from a gas cloud, we get the formation of stars and other objects that eventually become solids, or they can remain in the gaseous state, depending on many other conditions, which I don't want to get into here, but basically as these things form, they form into spheres. They form into the most compact form that they can, and hence that's why things are round. A long description perhaps, but I went into gravity, which is a very dominant effect, and hope you appreciate that. So that's what I wanted to say, perhaps a long-winded answer, but of course, you don't have to listen to the video. The other thing that we can, I'd like to pose another question for you, is as you see as we go through this course, I think the way I like to work things is to kind of ask you all questions. It's a sort of teaching method. Ask you a question, the question kind of makes you think, and as you think you sort of learn more, as you have to research things and you have to use your brain, so to speak, to put pieces together. Another point I want to make about astronomy is this is about visualization. A good scientist, a good astronomer, is someone who can see things. They can imagine. It takes a lot of imagination. They can imagine what it's like for an electron to be moving around an atom. Even though the human mind doesn't really understand what's actually happening, it's good to be able to visualize. We'd like to be able to visualize an expanding universe. Sort of the other end of the spectrum of sizes is things pushing away from each other. What is that like? So if you can't imagine it, it's very hard to enjoy the subject. So in a way, I encourage you to make pictures in your mind of what's going on. When you read about the rings of Saturn, make a picture in your mind of these rings, which are really fine particles moving in some kind of orbit around the planet. So really the rings aren't themselves solid objects, they're little dust particles which from far away look like solid particles. That's the name of ring. Let me pose the last question to you, and since we're really in week one talking about what the field of observational astronomy, you should go out there and look at some stars. Often I get excuses, well, it's cloudy tonight, we're having a hurricane, it's raining, the fog rolled in. Okay, in that case you can't see any stars, but the chances are over a week or two you'll have an opportunity. Go look at a star, and one thing you notice is the light coming from a star is not steady. It twinkles. Hence the famous song, "Twinkle, Twinkle, Little Star." But not everything in the sky twinkles. If you look at the moon, if you look at planets, which actually you might think they're stars, but there's Mars, Venus, Jupiter, Saturn. They can all be seen by the naked eye from Earth. If you notice those, they really don't twinkle. They sort of have a constant glow. So why do some things twinkle like stars and some things have a constant glow, even though to the eye they may look about the same size? Something to think about, and we'll address that in the next video. That's all I have to say right now. Hope this was useful, and thank you. Talk to you soon. Bye-bye.